After we finish talking about the X-ray machine, the X-ray provides us with two-dimensional images. We will see today that the CT scan or the CAT provides us with more detailed images or three-dimensional images. These images help us to know more about the internal and the details of the internal structure and the organs, the depth, the dimensions of the organs of the human body. So in short, it is better, it shows more details than the 2D usual X-ray machine. The CT scan, first the CAT or the CAT stands for what? The C stands for computerized, A for axial, and T for tomography. Tomography actually stands for slices. The slices, and these are the basics of the CAT scan images, the basics of functioning. It is based on building up slices, packing up slices above each other in order to get finally a three-dimensional image. The machine, the important parts of the machine. The machine mainly consists of the table, the bed where the patient will lie, and there is the gantry. So the patient is lying on this bed. There is the gantry surrounding the patient. The gantry contains two important units. We have here the X-ray source, and on the opposite side exactly we have a group of detectors. What happens is that X-ray will penetrate the body of the patient and the details will be detected by the group of detectors from the other side. This procedure will be done several of times and from many angles, from several angles. The gantry will now rotate. X-ray will penetrate again and detect it from the opposite side by the detectors. Again, from this angle. And so on until this image over here is built. This is the slice. So here we see several slices. These are slices, I think, for the brain. You see, this may be the eyes, the nose. Anyway, these slices will be, so each slice is taken from an angle, as we said here. After this, the patient will, the patient will be moved in this direction, which is here the Z direction. Okay, and the process will keep going. So what's happening is that we have a spiral of penetration of X-ray through the patient's body. This will result in a series of slices that will be packed above each other. If we could imagine that this is one slice. One slice here is called pixel. When we move the patient in the Z direction on the table and we take images from several angles again. So what we are doing is that we are building slices as the patient is being moved in the Z direction. Every time we slide the patient, we take images from several angles until we build a three-dimensional unit. This three-dimensional unit is what we call the voxel. The voxel. Okay. Now you see here the organ is divided into several voxels. Let's take one of them, zoom it in. This is the voxel, this is the slice or the pixel. So as we slide the patient in the X direction and keep taking slices above slices, what we get at the end is a three-dimensional voxel. Building the voxels with each other. Of course, these things are all to be done in the computer unit. At the end, we come up with a three-dimensional image of the patient, something like this. Okay. So we can see that this is just a slide over a slice over a slice. Okay, and at the end the computer will build up this three-dimensional image. Understand? Okay, going now to our papers. I think here it's on page 17, your application papers. We highlight these things on this part. Here again they are showing a simple diagram of the CT scan. This represents the patient, detectors, the X-ray gun or tube, gantry is rotating around the patient, a collimator, lead collimator used to provide directional X-ray. The collimator is rotated. As I said, when the X-ray penetrates at different angles. Penetrating in different angles, as we said, provides us with the slice, two-dimensional slice or a pixel. Sliding the patient now along the Z-axis, getting the slices again, building up the slices together, and you get the voxel or the three-dimensional unit. Now when these units are built all together, we get the three-dimensional image of the organ. Okay? Now this is the end of the first part.